So let me give you a little bit of a course overview. To do that, let me explain sort of how the course is thought of, at least by me, and Arpan thought this was really good, and Arpan's really smart, so if he thought this was really good, maybe it's good. You can think of computer vision as being a relationship between sort of three ways of thinking about what goes on. At the top of the triangle is the computational model. Often that's the math. And I'll use an example from stereo. So here we're showing you sort of the mathematics, geometry behind, if you have multiple views looking at a point out there, how you could reason about it and how, what the math would be behind trying to find its actual depth, right? The idea, you know, here's the center of one camera, center of another camera, here's some point possibly here, 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 and by matching, we're going to be able to figure out what the depth is. Once we have the math, we can develop an algorithm. So here's an example of doing stereo by what's called just correlating two patches along an epipolar line. Don't worry, you're going to learn what these things are. And computing, say, the sum of square differences, just how well they match. And you would measure that. And the point at the minimum, that's what this bottom point here is, that would be the right match. And by knowing that match, I would know what the depth is. So that's the algorithm. And in the algorithm, when we describe it to you, in class or in lecture, the algorithm always works. But of course, the last point of the triangle are real images. And when you apply these algorithms to real images, you're going to find that, oh, you know, Professor Bobick, he just lied. Okay? In particular, what you're going to find is that to make these things work requires some reasonable amount of experimentation. So we'll give you images. In stereo, actually, we'll give you some scenes for which there exists ground truth. That is, you actually know what the right answer is, and the question will be, how close is your result to the right answer? The answer is going to be not really close because you're going to be implementing a relatively straightforward stereo algorithm. And the reason there are more complicated stereo algorithms out there is because the straightforward one doesn't handle all the little issues that show up in real image. This triangle of three ways of thinking about computer vision, computational models, algorithms, and real imagery, that's really, that triangle is how the course is structured. What we'll do is we'll develop the theory, which will explain to you why it's possible to compute these things, and then we'll show some algorithms that implement that theory by making certain assumptions or certain ways of going about handling the images. And then you'll actually apply them to real images, which have all of their own mysterious properties. That's going to be, we'll talk more about in a minute about the problem sets. The idea of the problem sets is to get you to understand sort of the interplay between the theory, the algorithm, and the images.